Okay, this is section 6.1, which is functions, and we're going to start off with a couple definitions. So ordered pairs can be used to show inputs and outputs. So the inputs are these x coordinates, the 0, 1, and 2, and the outputs are 1, 2, and 4. I like to remember it as input, comma, output. So our key idea is all about relations and mapping diagrams. So a relation pairs inputs with outputs, and it can be represented by ordered pairs or a mapping diagram. So ordered pairs we've all seen before is x comma y. And mapping diagrams puts all of the x's in one column and all the y's in the other. And it uses these arrows. Okay, so this would be 0, 1, 1, 2, 2, 4, just like it is on the side with the ordered pairs. So example 1 wants us to list the ordered pairs shown in the mapping diagram. So if my input is 1, my output is 3, that means my x coordinate is 1 and my y coordinate is 3. It really is that simple. The second one would be 2, 6. The third one is 3, 9. And lastly 4, 12. That's a simple example. This one gets a excuse me, a little bit more complicated. So I always start from the inputs and follow the arrows to the outputs. So this one is 0, 0, 0. And if you want to like highlight what you're doing, that's totally fine to help you. So this first one is 0, 0. The second one is 2, 1. The third one is 2, negative 2. And the last one is 4, negative 3. Here's two more examples of listing the ordered pairs. This one's pretty straightforward. It's going to be 0, 12, 2, 10, 4, 8, and 6, 6. So 0, 12, 2, 10, 4, 8, and 6, 6. Number 2, I'm going to have 1, negative 1, 1, negative 2, 2, negative 3, and 2, negative 4. So our last vocabulary word is a function. Is a relation that pairs each input with exactly one output. That's the main thing to take away. Each input can only have one output. And what I mean by that is negative 9 has an output of 0. This input only has one output, so that's good. Negative 2 has an output of 5, so each input has one output, so that's okay. Now this is where things get a little bit trickier, is with the 5 and the 12. Okay, you have to remember that a function has each input has exactly one output. Okay, so 5 has an output of 10. 12 has an output of 10 as well. Okay, they can have the same output as long as they just have one output. Okay, so A, yes, this is a function because, oh boy, each input has exactly one output. Okay, looking at B, this one's a little crazier. So 2 has an output of 4, or excuse me, negative 2 has an output of 4, that's okay. Negative 1 has an output of 3. And if I look at 0, 0 has an output of 5 and an output of 6. So 0 has two outputs, which makes this not a function. Because 0 has an output of 5 and 6. Okay, each input can only have one output. This one has two. Example 3 wants you to describe this mapping diagram. So I need to consider this diagram over here, okay? And I need to determine whether the relation is a function. Each input has exactly one output, so yes, it is a function. And then it wants me to describe the pattern of inputs and outputs. So I'm going to kind of make these carrots, And say from 1 to 2, I'm adding 1. From 2 to 3, I'm adding 1. And 3 to 4, I'm adding 1. Okay? But over here, the outputs are increasing by 15. So from 30 to 15 is 15. 30 to 45, I add 15. And 45 to 60, I'm adding 15. So if I was describing the pattern of inputs and outputs, I would say as the input increases by 1, the output increases by 15. All right, last problem. This one isn't on your own. So determine whether the relation is a function and describe the patterns of inputs and outputs in the mapping diagram. I only want you to do the second part for number 4. Okay, so what I want you to do right now is pause this, see if you can determine whether or not they're functions, and describe the pattern in number 4. Okay, and then press play and I will talk through the examples. So the pattern of outputs, I'm going to determine whether they're functions first. So this input, -1/2, has 2 outputs. So right away I know this is not a function. Right, and here, number 4, I know that each input has exactly 1 function, or 1 output, so this would be a function. Right, and I want you to describe the pattern. So here I'm decreasing by 3 each time, and over here I'm increasing by 2. Okay, so I would say function as the input increases by 2, the output decreases by 3. And that is it for section 6.1.